Hey guys, in this video I'm going to go through this Leetcode number 23, merge case sorted list. So this question was very popular. As you can see, it was asked by as many big names: Amazon, Facebook, Microsoft, Apple, Google, etc. And this question was marked as hard, but it's actually not that bad. Let's dive in. We are giving an array of k linked lists, and each linked list is sorted in ascending order. We need to merge all the linked lists in one sorted linked list and return it. So for example, we have one linked list right here, and 1, 4, and 5, and they are sorted. Right? The smallest number is on the left at the beginning in the head, and then go ascending order. This is the second linked list, the third one, and what we need to return is something like this. It's a ascending linked list that has all the numbers. Okay, so that's one example. The other two just an edge case where if we are not given anything, we just return nothing. Let's dive into the solution. So the idea here is we can throw all the numbers in a heap and then pop the number from the heap, and then we can get a sorted number. So the first one, so basically we throw all the numbers in a heap, and the first one pops off with the smallest number. The second one pops off will be the second smallest number, etc. And then when we pop off from the heap, and then we collect it, we catch it, and then push it to a newly created linked list. So that's the idea. It's pretty straightforward. Let's dive into the code to see how can we implement that. And first, we're gonna cover an edge case where if we are given nothing, there's no linked list in it, and then we just return a none. And then for all the linked lists, linked nodes in a linked list, while the linked node is not none, and then we push it to the numbers list. So we initiate the number list at the beginning, which is an empty list to start, and then we push all the numbers to it, and then we iterate it, and then keep pushing it to the next one. Also, we have a counter that keep track of how many linked node we have in total, and which will come into handy later on. So whenever we come across a linked node, and then we will add one to it. And then we need to use heap queue, and then we call heapify function on heap queue. And then now this nums list become a heap. And then we initiate a dummy head, which will grab the real head later on, which come into handy when we actually return the head, the real head. I initialize the value as -1, just mark it for the sake of it, because that means we are not using it anywhere. We can mark any number we want, but I just mark any -1 just for us to easy to keep track of. And while the count is not equal to 0, this one allows us to keep track of how many nodes that we're pushing in. So and then we keep decrease it by 1 each time when we run this while loop. And then we create a new linked node, and then the value comes from the heap. We use the heap pop, and it pops off the minimum value each time. And then we create a new linked node to catch it, and it will push it to the head.next. And then we move the head, and then by using this one, head equals to head.next, and then we decrease the count by 1 each time. And then at the end, like what I said before, we grab the dummy head.next, because dummy head really, like the name suggests, it's just dummy head to allow us to grab the real head. Let's run it. As you can see, it looks okay. Yeah, that's so much for the solution. So in terms of the time complexity, yeah, this number changes sometimes. Yeah, it's not very reliable. So in terms of the time complexity, is so this Heapify, so this part is basically big O of n being the total number of the nodes, length node, right? We collect all the numbers, and the Heapify function is a constant running times big O of 1, and then heap pop is basically the log of n, and then we do that n times. So basically, it's a big O of n times log n. So when we jiggle everything together, so it's big O of n plus big O of 1 plus big O of n log n. So the entire runtime will be dominated by a big O of n log n. So that's the time complexity. For space complexity, that comes from the nums, which takes off a big O of n, which subsequently gets heapified, and also we need a link, the newly created link list, so that takes a big O of n as well. So yeah, so that's the space complexity, and that's about my solution. I hope you like it. If you do, please like this video and consider subscribing to the channel, and that will be a huge encouragement to me to create future videos looks like this. Thank you so much for watching. I will see you in the next video.